Hello, and welcome to Physics for Play. In this episode, we're going to be exploring some tips and tricks for using Mathematica, and we'll show you some keyboard shortcuts and generally familiarize you with how the software works. Let's get started. So, Mathematica is kind of like having a high-powered power tool for doing mathematics. So you can think of it this way. If solving a math problem with pencil and paper is like hammering in a nail, Mathematica is like using a super high-powered nail gun. And much like using a super high-powered nail gun, if you don't know what you're doing, you could end up in a lot of pain. So we want to make sure we give you folks some tips and tricks that'll get you started in learning the syntax of how to use Mathematica. First things first, I'm going to do a simple math problem here. I'm just going to type in 1 plus 1. Now you'll notice, if I look to the right over here, you see this little bracket. That bracket is the cell that I am in. And to do an evaluation, you have to be in the cell that you're evaluating. So if I click out here, nothing will happen. But if I click anywhere in the cell and I go up to evaluation and I click evaluate cells, it will spit out the answer for me. Now I can change this up as many times as I like. Now you may have noticed that there is a keyboard shortcut here. I highly recommend using the keyboard shortcuts and learning those because it'll go much faster for you if you do that. So to evaluate this to 1 plus 3, all I have to do is click in the cell and then hold down Shift and press Enter, and I get the number 4. Now, I'm going to change this one more time. I'll make that 1 plus 2, and I'll do 3 times 3 down here. Now, notice if I evaluate the bottom cell, the 3 times 3 cell, by clicking in there and then holding down Shift and press Enter, it doesn't update all of the other cells. It just updates the cell that you're in. So you want to pay attention to what cell you're evaluating, because if you don't, you can have a bad time. So that's important feature number 1. The next thing I'll point out, as we mentioned earlier, Mathematica has thousands of functions. One thing you want to do is make sure you're not naming your variables after existing functions because you'll get an error. And an easy way to do that is to put your variables in lowercase letters. So for example, if I were to type sine of x like this, and I were to evaluate it, actually let me give it a number. So we'll say sine of 3.14159. You see nothing happens. It doesn't give me the sine of 3.14159. And the reason is that sine, as I have written it, is not a function. All functions in Mathematica begin with a capital letter for the first letter. So if I evaluate this now, I should get some number close to 0, which I do, because sine of pi is 0. Now, a couple of other things you might have noticed. Thing number 1, before I made it an uppercase letter, notice how the text on the sign is blue. Any variable that is, text that is blue means that Mathematica does not know what that is. It is undefined at the moment. So if I write this as sine with a capital letter, notice the color changes back to black. If it's black, Mathematica knows what that is. So the 1 is black, the plus sign is black, the 2 is black. Mathematica knows what all of those symbols are, but if I give it lowercase sign, it does not know what that is. Now, you may also have noticed that we didn't quite get 0, and the sign of pi is 0. But we've got a rounded off version of pi here, so it's not going to give us quite the right number. What I could do is I could put in the symbol for pi, and you'll notice again if I do lowercase pi, it's blue. Mathematica doesn't know what that is, so it's just going to spit back sine pi at me. But if I give it an uppercase pi, Now the pi turns black. Mathematica knows what I mean. Sine of pi is 0. So that's one way of putting in pi. The other way, if you want to be like one of the cool kids, is you can use the actual symbol for pi. So the way to do that is you're going to hit the escape key and you're going to get these 3 dots. Then you are going to hit the letter P, and you'll see you've got a whole host of recommendations that Mathematica will give you. We want pi, so I'm just going to hit escape, P, escape, and I get the symbol for pi, and I evaluate that, and I get 0. If I want to make sure that works, let me just throw in pi over 2. Pi over 2 should be 1, and I get 1. Now, this does not just work for pi. You can do the same thing for any Greek letter. So if you're used to having Greek symbols in your equations in your textbooks, you can do that perfectly well in Mathematica as well. So all you need to do is remember the English equivalent of the Greek letter. So for example, if I want the symbol alpha, I would hit escape, and then the equivalent English letter is A. So escape, A, escape gives me alpha. If I do escape, B, escape, I get beta. If I do escape, G, escape, I get gamma. If I do escape, D, escape, so forth and so on, you get delta. So you can use Greek symbols. You can also use symbols like you would get in the English language, or mathematical symbols like, so for example, you could get the symbol E. I'm actually the symbol for E is just the exponential E, which you can do with a double E, just like that. You'll notice this is different than the actual letter E. You can see it's kind of a funny script E, and I can tell that this is the E because, again, it's in black. Other keyboard shortcuts which are useful, if you hit Control / you can get fractions. If you hit Control and then the caret symbol, you get exponentiation, and we can run these easily enough. Oops, I messed that up, and I see what I did here. So I put these two in the same denominator. Let me just fix this. I put the 2 to the 2 in the denominator of the top thing. It was just formatted a little weird. Let me run that again. So you get 1/2, and 2 squared is 4. You'll notice that when I evaluate this 1/2, it gives me 1/2, not 0.5. The reason for this is that Mathematica is not going to make any assumptions. So being a symbolic programming language, it's perfectly capable of handling exact integer fractions. So it's not going to jump over to giving you 0.5 because that might have some round off number if it's a floating point number. Now, that being said, if I put a decimal number in here, it will do the rounding off and it'll give me the 0.5. You can also explicitly tell you to give it a decimal with, I think the command for that is just n, the function n. One other place where it shows up where Mathematica is not going to make any assumptions for you is when it's doing other algebraic manipulation with symbols. So let's say, by the way, I should point out, if you are either lazy or you just don't know what a keyboard shortcut is, but you still want the nice formatting, there's a bunch of different math palettes up here that you can open up. I'm going to open up the basic math inputting palette here, and I'm going to choose a square root. And if I want to put x squared in there, I can use the exponentiation function like that. Now, what is the square root of x squared? Easy enough, that should be x. But if I evaluate this, you'll notice that you don't get x squared. You don't get x, rather, you just get square root of x squared. Again, the reason for this is Mathematica is generally not going to make any assumptions about what x has to be. And you get two solutions for square root of x squared. You get plus x and minus x. So there are assumption functions that you can use in Mathematica. I'm not going to get into it right now, but it's just something to pay attention to if you're confused why the number's not reducing in the way that you want. Personally, I find this to be incredibly helpful. So when I am doing calculations with pen and paper, a lot of times I will make assumptions that are not generally true. And it's very difficult to catch yourself making those assumptions. So I might just write down one solution, the solution square root x squared equals x. Using Mathematica, it forces me to catch those mistakes before I make them, because they can oftentimes cause problems down the road. Now you might notice that each of these cells, we've got quite a few of them now, have some output to them. And you might not always want to see that output because it gets messy very quickly. The command to suppress the output is just a semicolon. So we can just do that, and then it won't output the end of the line. I'll delete the rest of these. But yes, if you put a semicolon at the end of a line, Mathematica will not give you the output for that line. What about comments? So you always want to make sure you're documenting your code. If you want to put comments directly in the code, you usually use parentheses and stars. And I can say this is a comment. One of the nice things about Mathematica is that it has really kind of neat formatting options. So for example, I can come up here and I can change my format style to title. And I can say tips and tricks. And I have a whole bunch of different formatting options. So you have subtitles, chapter titles, sections, subsections. If you want to put text in, again, you can just click up here, or you can use the keyboard shortcut Alt-7. I'll do Alt-7 right now. But this just gives you essentially a text box where you can put comments, describe what you're doing in the code cells below. I find this really useful because it kind of makes your notebook, your Mathematica notebook, look like an actual pen and paper notebook, like you'd take notes in, but with a lot more functionality, and a notebook that does your calculations for you. So pretty neat as far as I'm concerned. Now, one more bit of advice, and this is, I would say, the most important bit of advice that I will give you. So you'll notice here, I wrote out alpha, beta, gamma, delta. Let's see what happens if I evaluate that. All of a sudden it says 3 beta, gamma, delta. And you might be scratching your head and say, why does it give you a 3 there? Well, the reason is, and you can see it here, I've defined alpha already, and you can tell because it's black. Whereas the blue, gamma, and delta are, the beta, gamma, and delta are all in blue text, which means those are undefined. And this can cause problems when you're working with a big notebook or even multiple notebooks. So if you have defined alpha in another cell, that definition doesn't go away. So I, before creating this tutorial, defined alpha to be 3. And at some point you can come into a really long calculation, and it could be code that you've used a million times, and yesterday it was working great. You didn't change anything, but all of a sudden it's not working anymore. Well, usually what happens in that case, I've found, is that you evaluated some cell somewhere else where you defined a variable and now you're trying to use it in a different context. So I would say one of the most important tips I can give you is if ever that happens to you, if ever you can't figure out what's going on, why things aren't working, just go up to Evaluation, go to Quit Kernel, and just quit the kernel. This will reset all of your variables so that anything you defined previously is no longer defined. So my alpha is no longer going to be a 3, and if I reevaluate that cell, I should just get alpha, beta, gamma, delta again. It's just kind of a reset button that allows you to go back to the base state where nothing's defined, and that usually clears up most of the problems that you have if you run into this issue. Well, that's going to be it for now. So check in with us in our next video where we'll start to dive into how to use this code and some of the tips and tricks that we've discussed today to actually solve some physics problems. Hope you had a good time, and we'll see you next time.